So for the first talk of the afternoon, we're going to switch back to the topic of macOS malware. So Rosanna is going to talk about classifying macOS Grayware. So round of applause.
So, hi everyone. I am Rosanna Charles. I work at CrowdStrike as a threat analyst on the MLOps team. My job sits at the intersection of MLOps and threat analysis. So today's topic is about Grayware. This idea actually started right here at OBTS last year. I remember sitting in the audience, listening to all the amazing talks on infestealers and spyware, and I had this thought, wait, what about Grayware? So later that day, when I got back to my room, I made a note in my phone that said, dive into Grayware. The idea was to explore the behavioral evolution of Grayware on macOS, but it turned into something a bit more actionable. So that little note that I made in my phone almost a year ago turned into the talk that you're about to hear today. So thank you, OBTS, for sparking this idea. My interest in Grayware began in November 2024 when I came across an adware called drag and drop. So when I saw that it was mentioned yesterday, I got a little excited. What caught my attention is that some variant dropped a backdoor written in Crystal, which had an embedded domain in it. And yet, strangely enough, it did nothing. That mystery sparked my curiosity into Grayware. OK, so here's the agenda for today. First, we'll start with a brief introduction to Grayware. From there, we'll look at the limitations of static labels. Then I'll introduce a behavioral labeling rubric. Then we'll walk through an Adload case study. And finally, we'll wrap up with next steps and key takeaways. Before we dive in, let's ground ourselves in the basics. What do we mean when we say something is a legitimate software, a grayware, or a malware? By definition, a legitimate software is a software that is installed intentionally, behaves as expected, respecting user consent and system rules. Some examples are productivity apps, IDE, and some browsers. Some key traits are transparent installations, user-driven actions, and minimal security risk. A grayware, on the other hand, is a software that isn't outright malicious, but engages in deceptive, intrusive, or unwanted behaviors. Some examples are adware, toolbars, system cleaners, PUA or PUPs. Some key traits are misleading consent, persistence, ad injection, data collection, and bundling. Malware is a software intentionally designed to cause harm, steal data, and exploit systems. Some examples are ransomware, Trojan, and spyware. Some key traits are covert installs, destructive payloads, C2 communications, and credential theft. For a moment, I want us to rethink how we see Grayware on macOS. Because traditionally on macOS, Grayware has often been treated as a nuisance, things like toolbars, pop-ups, and minor adware. But in reality, Grayware is evolving. Many families now use techniques that we often associate with malware: persistence mechanism, obfuscation, and even encrypted payloads. And yet, in most public datasets, these are lumped under labels like adware.generic or PUP.optional. The problem is our labels haven't kept up. Static labels often flatten very different threats into the same bucket and don't tell us much about operational risk. The goal of this talk today is to share a framework for classifying grayware behaviors, using Adload as a case study, and to show why the gray zone deserves more attention. So with that framework in mind, you may or may not be wondering why grayware thrive on macOS. And that's because the gray zone shows up here in a very particular way. They exploit trust. First, Apple's notarization process, designed to weed out unsafe apps, but grayware often slips through, giving it a false sense of legitimacy. Second, the system leans heavily on user consent. Many threats exploit this by presenting deceptive or safe-looking prompts. Third, configuration profile, a feature meant for enterprise management, but is often abused by grayware. Binary trust model, sign does not equal safe. This combination makes macOS a Grayware playground. Threats can hide behind the platform's own trust model while undermining user experience and security posture. So let's look at this chart from A/B tests. The data shows that Grayware and malware on macOS have both increased over the year. Notice how the bars for Grayware tracks right alongside malware and sometimes even outpacing it. This trend challenged the assumption that macOS is mostly clean and that Grayware is a minor issue. I'm sure if we go on any macOS forum, we're going to see a few posts stating that macOS is immune to virus or malware, and that is something that we all know is not true. So let's take a step back and compare some behavioral traits of Grayware in 2014 versus 2025. In 2014, Grayware mostly meant aggressive pop-ups, toolbars, bundled with free software, or browser hijacking. Annoying but not particularly complex. Fast forward to 2025, we now see stealth install, persistent launch agent, malicious configuration profile, and even covert data collection. This isn't nuisance software anymore. It is something that actively resists removal and manipulates the operating system. So up until this point, we've examined how macOS Grayware have evolved over the years. But why have these threats become more stealthy and persistent? The answer is simple. It's because of money. Grayware is designed to make money, so let's explore a few ways how. Pay-per-install, or PPI. Developers can earn money each time a software is installed. This incentivizes bundling with other applications and silent installation. Some studies have found that commercial PPI schemes can earn up to $460 million per year. Bundling with legitimate software. Adware often piggyback on popular apps, increasing the number of installs without user knowledge. For a bundle installed from a Tier 1 country, developers can earn anywhere from 15 cents to 50 cents per install. Affiliated marketing and ad revenue. Some adware collects browsing data and affiliated marketing ad revenue, redirects, injected ads, or pop-up generate money every time the user clicks or visits a site. These methods can be highly profitable, contributing to the overall revenue of adware campaigns. Data monetization. Some adware collect browsing data or user profile to sell or use in targeted advertising. The key takeaway here is financial incentives drive the technical sophistication we see today. More stealth, more persistence, more complex payload. Essentially, each behavior we observe in Grayware has a business rationale behind it. And by understanding these incentives, we can better contextualize the evolution we've just discussed. These threats are not just nuisance anymore, they're engineered for profit, which is why they continue to evolve. During my research, when I was trying to determine what Grayware to use in my case study, I came across a video on period adware. I think it was by Amit Sapar. And the title of that video was "Adware is just malware with a legal department." So for a moment, let's do a challenge. What if we look at behavior without label? What do we call it? So I mentioned drag and drop earlier in the talk, and here's an execution chain of one of the variants of drag and drop. So imagine an app downloads a script. Imagine an app runs a script and downloads an additional payload to the temp directory. That payload communicates to a known adware or malware site, and also communicates to an additional C2 and just sends system information. What would you call this? Is this malware, Grayware, or something benign? The point is, labels alone don't answer the operational question. What risk does this pose to my environment? And that is where traditional labels tend to fail us. When something is tagged as not a virus or PUP.optional, it's automatically deprioritized. Unless assumes it can wait. But behind those labels can be a piece of malware that installs persistence, proxy traffic, or collects sensitive data. Static categories oversimplifies, oversimplifies threats that are much more dynamic. So what's the alternative? Multi-behavioral labels. And multi-behavioral labels are built from observable behaviors instead of static categories. Some advantages: it captures the evolution of and overlaps of Grayware that looks a little like malware and Grayware that pretends to be a legitimate app. It helps teams prioritize Grayware that carries real operational risk. So now that we've talked about the limitations of static labels, let's get into the rubric. Here's the scoring system I propose. Each behavior is rated on a scale of 0 to 3. 0 means the behavior isn't present, 1 means it's basic or benign use, 3 means it's clearly malicious or deceptive. This gives us a way to score behaviors across families, versions, or even single hashes. While looking at a number of samples, I noticed that Grayware usually have 3 or more of the following categories. The first 3 that we're going to look at are deception, persistence, and monetization. Deception looks at how the user is misled, from barring disclosures in EULA all the way up to fake antivirus pop-ups or full-on impersonation. Persistence looks at how hard it is to remove, from simple login items to launch agent, all the way up to tampering with security tools or system files. Monetization covers how the attacker makes its money. This can include ad injection, affiliated clicks, crypto mining. Understanding monetization behaviors help teams prioritize threats based on potential business or user impact. The final 2 are consent violation and payload activity. Consent violation measures whether the user knowingly approved the install. Was it opt-in, opt-out, or silent drive-by? Payload activity looks at what happens after install, from silent updates to full C2 communication, exfiltration, additional Grayware or malware drop-in. So let's take this. Okay, so let's take this from theory into practice. Say you've got a hash or a suspicious sample. Here's a high-level overview on how you can actually apply behavioral labeling. Step 1 is telemetry collection. Whether you're using EDR, sandboxes, process monitoring tool, or a combination of tools, you want to capture what happens at install, execution, and post-execution. For example, logs from a PKG file or when OSA script or curl are invoked. Then you want to check for persistent artifact and network telemetry. Step 2 is applying the rubric. Take the behavior you've just observed and score it across all 5 categories. Using both launch agent and configuration profile gives it a 3 for persistence. Monetization through ad injection earns a 2, and for consent violation, a silent install with no user consent is a clear 3. Finally, step 3 is operationalize. Once scored, you can apply thresholds. For example, a sample hits 2 or more 3, it's automatically flagged as high risk and routed to higher triage queues. The key takeaway here is we're no longer relying on a single oversimplified label. You're evaluating risk based on behavior. All right, so here's a sample that we're looking at. At first glance, nothing really jumps out. It was signed and notarized, and if you check VirusTotal, detections are missed. Some vendors call it adware Trojan, some call it generic, some has PUA, some no detection at all, but that does not mean that that vendor does not detect this specific hash. So first, we're going to look at this activity, then move through network behaviors and system changes. So after installation, the sample quietly creates a randomized folder under library application support. Inside, it drops a proxy executable, and then it writes a launch agent plist into library launch agent that points back to that binary. The launch agent acts as an anchor and makes sure that the proxy comes back after login and reboot. Next, network activity. The host phones home to a C2, sending basic system information and receiving instruction to fetch or activate the proxy payload. After activation, the infected Mac basically turns into a residential proxy node, forwarding traffic for third parties. Process behavior. So let's look at process behavior. On the process side, the proxy runs quietly in the background. In some cases, it replaces an existing proxy process or hijack network traffic. System configuration. Some variants tweak local network or DNS settings to make traffic routing easier. But interestingly, there's no use of configuration profile. So if you put this all together, we have randomized app support folders, launch agent persistence, new background proxy process, and outbound traffic to C2 or payload domains. This gives us a strong behavioral fingerprint for this adult sample. Instead of chasing one IOC at a time, you prioritize correlating files, processes, and network telemetry. So let's break it down using the rubric, which scores across the 5 categories that we talked about earlier. Starting with deception, the installer was signed and notarized. It masquerades as a legitimate utility, often under names like App Assistant. It contains a hidden payload called main or helper. It relies heavily on Apple's trust ecosystem to convince users that it's benign, so it scores a 3. This is sophisticated trust abuse strategy, not just typical nuisance Grayware. Persistence. Post-install, the sample drops launch agent plist in files into library launch agents and spins up a background process that runs continuously without visible user interaction. It also writes out a marker file, which acts as a lightweight persistent check for reinstallation. This is multi-layer persistence, and it survives a reboot, so it also scores a 3. Monetization. So here's where this sample crosses a key line. Instead of just hijacking traffic or injecting ads, it spins up a fully functional proxy node on the infected host. This involves traffic rerouting and turning endpoints into residential exit nodes. This is major operational abuse, so monetization earns a 3 as well. So content violation. While the installer technically presents a prompt, it's misleading. Users are tricked into approving installs without understanding what they're enabling. There's no meaningful disclosures, and the persistent file it drops makes removal non-trivial without admin tooling. This is coerced or uninformed consent, so that scores a 3 as well. Finally, payload activity. Post-install, the sample downloads additional signed proxy binaries, assigns a unique ID, and evaluates the host's hardware characteristic to determine its suitability as a proxy node. These are deliberate programmatic action that goes far beyond adware norms. For that reason alone, payload activity scores a 3. So this sample score a 15 across the board, which is the highest possible score that a sample can get. And taken together, the score paints a clear picture that this isn't a low-risk Grayware. It's high deception, robust persistence, and active participation in proxy abuse infrastructure. So let's look at what a behavioral label would look like in practice. Instead of just using static labels like adware.generic, which tells you very little, you can enrich the labels with the behaviors we've actually observed. For example, this same sample might be tagged as adware downloader, deception, payload, sign install. Now, immediately, it communicates why it matters. It's a downloader, it engages in deception, it drops a payload, and it installs silently. With just one line, the label is no longer a static tag. It's a summary of operational risk. Analysts can see at a glance what the software is doing and why it deserves attention. So the operational benefit of behavioral labels. Simply put, alerts compete for attention. And if Grayware gets flagged as harmless bloatware, analysts are likely to ignore it. But what if that Grayware is persistent, stealing data and hijacking traffic? Behavioral labels let analysts triage based on behavioral risk and not just category. It improves triage, reduces burnout, and surface threats that are hiding in the gray zone. So, some key takeaways. Static labels flatten nuance and often hide operational risk. Team Workflow can prioritize Grayware with malware-like traits. It enables detection tuning, triage routing, and alert enrichment. It's meant to complement rather than replace current labeling practices. So this was an independent initiated project, so I am grateful for my team for supporting me coming here and presenting. In the future, I'm hoping to make this automated or AI-driven. That is something that I wanted to do before this conference, but it's a huge undertaking that will take a lot of time and a lot of data. I have some additional slides that I want to discuss if the time permits. So applying the rubric, I applied it to a 2016 sample and a 2025 sample to show behavior drift across adware. So in 2016, a sample scored a 6, and in 2025, it scored a 13, which shows a clear escalation in behavior. And this is a more zoomed-in approach that tracks along from 2016 all the way up to 2025, and there's escalation applied to all 5 categories, and there's escalation in behaviors across all 5 categories here. And here, the rubric was applied to Period, MacKeeper, and Adload, and we're showing that the rubric can be applied to other families as well. And thank you. That's it.